Good afternoon. Thank you once again for joining us here on Facebook Live. Once again, I'm Amber Kastner, the Public Science Events Manager here at the Bell Museum. And we're excited you've decided to join us once again for our monthly presentation where we explore what can be seen in the evening skies throughout the next month. Today, we're going to be exploring what you can see in November. And while it may take a little bit more bundling up to see the stars in November and December, these are some of the best times to be able to observe the evening sky when things are super clear, albeit very cold. Today's observations are going to come to you from Thaddeus, our Bell Museum planetarium educator, and he's got some screen shares and lots of great things to show us. We hope that you're excited to learn more about what to see in the evening sky. Tell us, Thaddeus, what should we be looking for in the month of November?
All right. Thank you, Amber. We've got a lot to look for. Well, you know what? I'm just going to get right into it, and we'll see what's going to happen along the way. All right. So for anyone who's seen me do this before, I love to use the program Stellarium. This is a free open source piece of software. You can download it yourself. You can get it on your computer, like I'm doing here, a laptop, phone, tablet. They have it for all sorts of devices. And you can set it to see the sky from anywhere, anytime. I'm just going to do from right here in Minnesota. So St. Paul, Minneapolis, it defaults to Minneapolis here. But we're looking at the sky here on November 11th. Got my time and date set up down there at the bottom. And about 7 o'clock here on the beginning of November, looking to the south. Now, throughout the month, there are going to be, again, a lot of different things to see. I do always recommend just starting out to the south, though, if you're going out stargazing, especially if you're not sure exactly where to look for things. If you're not sure where the south is, we'll actually get to that just a little bit later on. For right now, though, well, just maybe find a compass app. That's actually what I have on my phone. It works really well. But looking to the south here, if you're here inside the city, you're probably not going to see all the stars that I've got displayed on my screen. If you can see the faint band of the Milky Way here, you also probably won't see that if you're inside the city. In fact, I guarantee you're not going to see that if you're here inside the city. Our light pollution here in the Twin Cities is, well, we've got a lot of light pollution. Makes it really hard to see the night sky. If you can get a little ways away from the city, 30, 45 minutes away, out to some of our great state parks, and of course, if you can go all the way up north, it's going to be it's a fantastic sight. Again, it is very cold this time of year, so make sure you are dressing very, very warmly. Wear lots of layers. As always, stay safe so that you can stargaze far into the future. But as Amber said, the winter is, of course, we're here in fall, but the colder months are one of the better times to go stargazing. We do get longer hours of darkness. Here, just looking at the sky at 7 o'clock, it's already going to be dark in November. And that will continue until well in the mornings, 5, 6 o'clock. It's also generally, because it's colder, the air is usually stiller, so it's not moving around as much. And that makes it just that much easier to see things. Without so much air movement, things in the sky like stars, they don't twinkle quite as much. There's not as much atmospheric disturbance. So for those reasons, and some more, the winter is a great time to go stargazing. Again, just stay warm. All right. And if you don't like going outside doing stargazing, that's why some of us go out and do it for you, I guess. I don't know who those people are. I'm not going to be one of them, though. All right, looking here, though, to the south. Let's get into some of these things. All right, looking right to the south, some bright stars you will see if you are inside the city. I know you'll see them. I see them basically every night here during the summer. They're still visible for a few hours in the fall-winter sky. Looking high up above us, looking a little bit to the southwest, in fact, we have the bright star Vega, which is part of the constellation of Lyra, or the Harp. If we come down from Lyra here, Vega and Lyra, we can find the bright star Altair, part of this constellation here, part of, turned on too many constellations there. Part of Altair. Altair is part of Aquila, the eagle. And finally, if we come up here to Deneb, I already gave it away, we have Cygnus the Swan. Now, these three stars right here, Deneb, Vega, and Altair, you probably already know them if you're looking at the sky this summer. They form a grouping called the Summer Triangle. Pretty simple shape here. Now, what we've been able to do for the summer and what we can still do here in November is you can take the Summer Triangle and you can point downwards. Just follow that triangle straight down to the horizon and look for 2 bright points of light. Now, these 2 bright points of light will look a little bit different from the stars from Vega, Altair, and Deneb. These 2 points of light right here and right here will be nice solid points of light. They won't be twinkling. Now, here in the planetarium software, that twinkling might not be quite as obvious, but it's there very faintly. These 2 objects, since they're not twinkling, and since they're very, very bright, are a good, well, maybe just a giveaway to some of you that these are 2 planets. So in fact, over here we have Jupiter in the constellation of Sagittarius and Saturn. Now, we've had these for months. They're still in our sky, but they are getting closer and closer to the horizon as we look down here. So if you do want to see them, go out, hurry, take the chance. They're always a great sight to see, starting at Jupiter here with just a pair of binoculars and a good steady hand. You can pick out the 4 Galilean moons, these 4 bright points of light all alongside Jupiter. We have, I'll just turn some labels on here. Here's Europa, Ganymede, Io, and Callisto. And if you do watch these over the course of a night, over the course of a few hours, if you can, they will very slowly, very, very slowly move around Jupiter. It will take a couple hours for that to happen, so you'll want to start stargazing early and keep going for as long as you can. Again, if you're trying to stay warm, go out, take a look, draw a little sketch of what you see, and then duck back inside. Once you warm up, head back out. Try to stay out, though, for at least 20 minutes. Your eyes get dark adapted after it takes about 20 minutes for your eyes to get dark adapted. So once you get nice dark adapted eyes, you can see a lot more. So you've got to brave the cold for just a little while. All right, if you do have something more than binoculars, if you do have a telescope, if you're looking at Jupiter here, you might see actually what we can see right now, that there's a little dark spot on Jupiter. That's actually a shadow, a transit. Probably caused, I'm going to take a guess and say by Ganymede. It could also be by Europa over there as well. Or it could be one of the other 79 moons of Jupiter. It has, as you can see, already starting to be labeled there, quite a few. It does take a telescope to see something like a transit, though. They are relatively small compared to all of Jupiter. Ganymede here is only about 2,000 miles across. Jupiter here, well, Jupiter here you could fit about 12 Earths across. And if you know the diameter of the Earth, you can figure that out in miles. But looking here more closely at Jupiter, we can see the stripes, the bands in its atmosphere, where gas is rising and falling in the whiter zones and the darker belts. Some color change here as well, caused probably by ultraviolet radiation from the sun, changing some of the composition there in the atmosphere, causing hydrogen and helium and methane to break up and recombine into new things. So we're getting very excited about Jupiter here. Not as excited, though, as I will be about Saturn, leaving Jupiter behind. Saturn, if you look at nothing else, look at Saturn. A familiar thing to anyone who's ever heard me give a planetarium talk. Again, binoculars are nice. Binoculars, it won't be quite as distinct as Jupiter. You might see a moon like Titan. You might just see a bright oval through binoculars, which is already cool, though. It's very different from the other planets because of that distinct ring system. And looking with a telescope, you can bring into view looking and seeing that red ring system around it, maybe picking out the gap there, the Encke gap, an actual space in the rings where there's less material. Saturn is just, it is incredible. In fact, the view that you can see on your screen here is through a telescope is basically exactly what it will look like. It will never let you down there. And we're at a great time to see Saturn in its orbit around the sun. The rings can be tilted towards us. They can get tilted away from us. They can get tilted directly at us. Right now, though, the rings are nice. They've got an 18-degree tilt downwards, so we get a nice view of them. They're reflecting a lot of sunlight back to us from the ices that make up the rings. So it's great to see. As well, it's got moons around it. In particular, it doesn't have 4 nice bright ones like Jupiter and the Galilean moons, but I would recommend probably looking for ones like Tethys, pretty close in, or much further away is Titan, second largest moon in our solar system. Titan over here is also, as you can actually already see, it's very orangey. You might not see that color stand out through a telescope, but it is actually that color. It's one of the only moons in the solar system with an atmosphere made of nitrogen and methane and reflecting a lot of red orange light back to us. All right. I won't spend all of my time on planets. I will just spend a little bit more time, because as we look to the south here, we've got our summer triangle above us. Zoom back a little bit so we can see that again. Our summer triangle is still up over here. If we come around, though, and a little bit over, we start star hopping around, we can find some other bright stars. In fact, over from Altair down there, if we come over about a hand width or so, we can find the star Enif. Now, Enif here is part of a different constellation. This is part of Pegasus, the winged horse. Pegasus here is always drawn upside, the artwork is always upside down in every planetarium software I see whenever it's a winged horse. I have no idea why. But you can see Pegasus here in another way as well. If you just look for the 4 bright stars, Markab, Algeneb, Alpheratz, and Shiat, you can find the fall square. So just like we had our summer triangle, we also have our fall square in the sky. Very easy, very distinctive up there. And coming down, in fact, from these last 2 stars from Shiat and Markab, there's Pegasus again, they form a nice straight line, like a square should. If you follow them straight down, you'll find the star down here, Fomalhaut. This is part of Pisces Australis, or the southern fishes, or southern fish, excuse me, singular. Now, Pisces Australis isn't a very bright constellation. Fomalhaut is pretty much the brightest star in it, but it is very easy to see. Stellarium here, as you may have noticed already, gives a lot of information about the stars, the different names, as well as some different characteristics. This is a star, it's a magnitude 1 star. Magnitude scale is how bright a star is. 0 is actually measured from the star Vega, magnitude 1 being a very, very bright star. Other stars like Altair, you might have noticed, are magnitude 0.7. It's varies a little bit. We got Vega back up there, magnitude 0 or negative 0.02 for historical reason, not quite 0 for historical reasons, and so on. All right. So there are a few constellations there. Again, we've got Pegasus, we've got the Southern Fishes, bring up the Summer Triangle again. You can use these to orient yourself to the sky. And if you come way over here, looking over to the southeast, you don't even really need those constellations to see it. We have one more planet. The bright red point of light over to the southeast is the red planet Mars in the constellation of Pisces, the fishes. Now, Mars here has been in the news quite a bit. I won't repeat everything. You can look it up as well. Suffice to say, there are a lot of missions. There are 3 new missions headed to Mars right now. They're going to get there early next year. In particular, NASA's Mars Perseverance rover with the Ingenuity helicopter are due to arrive on February 18th, 2021. And if all goes well, fingers crossed, it will land safely on Mars. That's a big if, but hopefully it's going to happen. All right, looking at Mars, in fact, looking at Mars with binoculars or telescope, I'm not going to lie, it can be a little underwhelming sometimes. It's not quite like Jupiter and Saturn. Mars is a tiny planet. It's only about a quarter the size of the Earth. So it generally looks like a round red dot. It is a very bright, nice round red dot. It does have that distinctive color to it coming from the iron and the rust on its surface. But to see the real detail on the surface itself, you'd need a pretty large telescope, 6-8 inches or larger, pretty dark skies, and you're going to need to spend a lot of time with it. It takes more than just 20 minutes to get dark adapted to start seeing features on the surface of Mars. It can take days or weeks of patient observing and sketching as well. Sketching is a fantastic way to help your brain, your eyes, and your brain remember and understand what you're seeing in the sky. And of course, if you have a camera and you get into astrophotography, you can bring out some great images of Mars, especially it's still very close to us. Right now, it's only 70 million kilometers, about 35 million miles away. So it's hop, skip, and a jump. And again, I'm trying not to talk just about planets. There's a lot more to talk about. So we can see here, though, some of the darker regions on the surface. We can see Hellas Basin over on the right, that bright area right there. We can see the very small southern polar ice cap. So if you are getting into looking at Mars, start out just by looking for those contrasting areas, the light, the dark areas. And that'll help you develop and see more and more there, like clouds over Olympus Mons. All right, but coming out, we are still amazingly enough just here on November 1st. But again, all of these planets and these stars, you can see throughout November. In fact, if I just start going forward a little bit day by day, make sure our planets are up there. Going to go forward to about the 10th. You can see they're still here. They've moved along a little bit, but they are still there. Our summer triangle is still up here. Our fall rectangle is there. We can also see with the labels up that Uranus is visible as well over to the east. You'll need binoculars or a good telescope to see that one. But as we go forward to the 10th, I'm actually going to take us forward in time. We're going to go forward to the morning of the 10th. We're going to go forward, in fact, to about 6 o'clock. So for you early risers there, there's something very cool happening. In fact, all throughout November, there's something cool you can see in the morning sky. We have two planets, though, one planet in particular that's going to be best seen on the morning of November 10th. This is the planet Mercury. Mercury is a very tiny planet, smallest planet, and it never gets very far above the horizon. But on November 10th, Mercury will be at its greatest western elongation. Its furthest distance from the sun, its highest above the horizon in our sky. So your best chance to go and see it. That being said, it's still not very high above the sky. In fact, we can see Mercury right down here as this little point of light nearby in the constellation of Virgo. And Mercury right here is only about 5 degrees above the horizon. 5 degrees or so, that's about, if you take your hand and you do just 3 fingers and you hold it out at arm's length, you can see that. Your fingers, 3 fingers at arm's length, that'll cover about 5 degrees of the sky. So you're going to have to look for Mercury very close to the horizon. That being said, and it is a very faint planet, so it's not going to be super bright like Jupiter, Saturn, or Mars. That being said, there's a couple easy ways to find it or to narrow down the part of the sky. And it helps if you start out even a couple days earlier. If you look at the sky earlier that month, we do have Venus over here. You've seen the label. It's hard to miss Venus, the brightest planet we can see in our sky, our morning star here in November. Mercury will be straight, not quite straight down, but a bit of an angle down from Venus. So if you're going out in the month and you can find Venus very quickly, very bright, and you can come down and start searching for Mercury that way. It'll always still be about the same distance and position away from it, and that can help you narrow it down. There's also a bright star Spica right here. It's a very nice blue star. It's a blue giant star. It's, again, part of that constellation of Virgo, the maiden. There's Virgo here. And you can see here on the morning of the 10th, there's a nice little triangle. And there is another way, again, looking forward in the month, going forward about 3 days here. Now, here on the 13th, Mercury won't be at its highest point above the horizon, but it'll still be pretty high above the horizon. It'll be easy to look for. And we also have our moon right here. So if you've got Venus, if you've got Spica, if you've got the moon, then you can, I think, pretty easily hop your way down to Mercury right there. A lot of different ways to find objects in the sky, and it does take sometimes a bit of time, going out over a couple days. But if you do put that time in, you can go see a planet that, actually, personally speaking, I've only ever seen twice in the sky. It's just that hard to see. And of course, going out multiple times throughout the month means that if it's cloudy or snowing on you one day, hopefully it won't be the next. But no promises. This is Minnesota. All right. Now, as well, here on the morning of the 13th, looking at the moon here, this will be our last crescent moon, very last little bit of it. So it'll be kind of like, it'll be almost like horns there in the sky. If we go back a day, it'll be just a little bit, still that last little bit of crescent there, but still visible and just a little bit above Venus. And since we're looking here in the morning sky, I'm checking my time as well. I'm going to take us back around to the south and a little bit to the southwest. Also, just a little bit back in time. All right. Now we're here mid-November. What I want to talk about next, though, you can see, fingers crossed, throughout all of November, always about around the same time, though, about 4 o'clock or so, looking to the south. And this is going to be the Comet. Should I get the name right here? This is Comet Atlas C20M3. Atlas C20M3. Not the catchiest name. I realize I didn't come up with it. All right, now Comet Atlas, we're just going to call it M3 today. I think that's going to be easier. Comet M3 is, on the morning of the 12th, it's actually all the way nearby the stars of Orion. So we can see here the 3 belt stars of Orion, his shoulder Betelgeuse, or Betelgeuse, Bellatrix, Rigel, Saiph, and so on. We've got the Hunter. It's Orion. You can't miss him in the sky. Now again, Atlas, make sure we'll bring it up here. It'll be at this location there. You will need binoculars at least to see Atlas. You might even need a telescope. Comets are very unpredictable. It could get a lot brighter. It could get a lot dimmer. But it will also be moving very quickly. In fact, if I just jump backwards to November 1st here, Atlas is going to be all the way down near Lepus, the bunny, one of Orion's his prey in the night sky. But Atlas there, or M3, whatever we're calling it, it will move quickly. So here on the morning of the 1st, but day by day getting higher and higher in the sky here as it keeps traveling around the sun, and as we keep traveling around the sun, as everything moves around. So by the end of the month, in fact, if we go all the way to, we can see here by the 25th, it'll be in the constellation of Taurus. M3 keeps disappearing on me. It'll be all the way in the constellation of Taurus. So you could look for the head of the bull here, the horns of the bull. That can help you track down M3. And just stopping here on the 30th, it'll be right in between the horns of the bull. It'll be, if it's, again, they're unpredictable, but if it's visible, it'll be very easy to find in the sky and hopefully easy to spot. I don't want to get your hopes up too much, though. Again, I've mentioned comets are unpredictable. It also may just look like, kind of like you see here, like another little fuzzy patch in the sky. Okay, maybe that's not like a giant nebula. Maybe it's not like the images that a lot of us saw of Comet Neowise a couple months ago, but it's still very cool. The seeing of comets are so cool because it might be a comet you only ever see once in your life. Although many comets are also periodic. They do come around more than once, so don't be dismayed if you miss one. Neowise was not one of those, by the way. M3, though, like all of the parts of our solar, all comets here, it's part of the original stuff that made up our solar system. So every time you get to see a comet, you get to look back into the past. You get to look back billions of years and just see a glimpse of what our solar system used to be like, and part of how the rest of it all came together. Matt, and when you see pictures, they are just really pretty to look at. So spend as much time as you can going out stargazing for them. It will be, if you're looking out on the morning of the 30th, there's also something else you should be doing too. In fact, here on the morning of the 30th, we have got a penumbral eclipse happening. So it's going to be very cool. What can I say? Of course it's cool. That's why I'm talking about it. But here we are looking, again, still to the southwest, and we have our moon. And we'll see if we can move our constellations. Now, this penumbral eclipse, this is when the moon is moving into just part of the Earth's shadow, the outer part of the Earth's shadow. So it will be slightly darkened. Now, this actually starts happening about 1:30 a.m. on the morning of November 30th. So November 30th, 1:30. Here we're at 2 o'clock, and you can actually see, if you have good eyes here, it's actually already a little bit darker. Now, if we start going forward in time, maybe try not to go too far, overshot just a little bit there. Going here about, and maybe we'll do this by steps then. Going forward to about 3 o'clock, the moon is just a little bit darker. And see if we can do this one more time here. And this penumbral eclipse will reach the greatest extent, the darkest part of it, at around 3:42. So about 3:45 here. And we can already see, if you're really keeping a good eye here, you can already see that happening. You can see the moon getting just a shade darker. And as we stop it, try to stop here, 3:42. Ooh, almost on the dot there. We can see the extent of this. Okay, it's not a total eclipse. I get it. It's not a total eclipse of the sun like we had in 2017, which was incredible. A penumbral eclipse doesn't have quite the same wow factor. But again, just like a comet might not have the same wow factor at first glance, if you spend enough time here just looking at it, watching the change here over a couple hours, you're seeing this motion in the sky. You're seeing the moon really moving around us and moving into different parts of its orbit. You're seeing the shadow of the Earth. The Earth here, this 8,000 mile across behemoth, you see it blocking light from the sun. And that's pretty cool. And it is a full moon here, which is always cool to look at. So if you've got binoculars, you've got those telescopes, take a look at the moon. Look for some of these magnificent craters all across the surface. Look for the dark seas, the Maria across it. If you have good eyes, you might see Tycho crater down around the southern-ish pole of the moon, the long rays streaking out from it. And here during the full moon, we've got all the light of the sun reflecting back to us here on Earth. And we're not the only ones looking at the moon. In fact, scientists all across the world continue to study the moon. And just this morning, NASA actually had a press release, a really cool announcement that they detected water on the near side, the sunlit part of the moon. NASA, we've known about water for quite a while in the moon, but we've mainly only known about it at the bottom of craters on the moon, where they never reach, where sunlight never hits the bottom. One of these giant craters where it's just so deep that sunlight never reaches it. We've known about water there for a while, and that was a cool discovery, and it makes sense. Sunlight never reaches it, so water got there, maybe from a comet smashing into it, an watery asteroid hitting it. Cool. But now NASA's found that just in the rocks of the moon, there's water locked away. This water probably occurs when hydrogen atoms or oxygen atoms are struck by charged particles from the sun. That causes them to combine together into H2O molecules. That's pretty common, but we're finding more water than we expected. It's still pretty dry, but about a square meter, a square yard of lunar rock would give you about 12 liters of water. That's really cool because that's for human purposes and for what we could excavate on the moon, that's a lot. In fact, that means that we could potentially set up giant harvesters on the moon, breaking down rock, releasing water, and using it to supply water for a human colony on the moon, or at the very least for human astronauts on the moon as we get back there in the next few years. So the latest discovery here by NASA is very exciting because it just opens up a world of possibilities for what we can do in the future. And this discovery was made, I want to mention, in another very cool way. It was made using SOFIA. And SOFIA is a telescope. It's the Stratospheric Observatory. Hold on, I'm forgetting the name here. I want to make sure I get this right. I'm just going to do a quick little search here. Stratospheric Observatory for Infrared Astronomy. So SOFIA is a modified 747. So NASA got a 747 and they put a telescope inside it. And they put this 2 meter telescope inside it. And it flies 40,000 feet above as much of the atmosphere as we can. And it does observations of the moon. It does observations of stars, of galaxies, of nebulas, of all sorts of different things. It's one of the coolest, I think just technologically speaking, especially, but just for audacity's sake, one of the coolest pieces of technology we have these days. So SOFIA made these discoveries, and it will hopefully continue making other cool discoveries far in the future. All right, Amber, I know I always run through time so quickly. I left a minute here, though, at least, for questions. What do we got?
Thank you so much for that. I appreciate you jumping in on NASA's news today. It was one of the questions that I was going to ask.
Oh, good, yeah.
And
did that hopefully answer? Were there more?
No, absolutely. I think people are just interested in wanting to know a little bit more. I know you also at the beginning talked a little bit about the software you're using, and I wonder if you could revisit that a little bit. Thomas is just wondering what it is and where he can get it.
Sure. So I brought up the help. This will be better because you can read the words here. So it's called Stellarium, Stellarium. I'm on version 20.3, which I think is the latest, and I think I've only crashed it a few times. 20.2 is also a good one. They're all stable, but 2020 is the latest one. And to get it, I want to see if they list a website here. There's some keyboard shortcuts. but it should just be stellarium.org. So stellarium.org. There is also as well a web-based version of this. Ooh, hard words. A web-based version. It's linked on the website. So you don't need to install anything, actually. It's not quite as detailed. You don't get all the things, but you can definitely explore the sky from different places, from different times, and see what's up there. So it's fantastic. It's one of my favorite pieces of software, and I highly recommend it. They don't pay me to do this. If they do want to, I probably wouldn't take their money. It's free and open source. I would give it right back to them because they do such cool work. You're all the developers on this.
Thank you. Thank you so much for that. You'll be happy to know that Anne is also enthusiastic about winter observations, commenting there is no bad weather, only bad clothing, which I think is a good thing for all of us to remember.
That's true. Do they make mobile igloos? Because that's kind of the thing I would like just a hut that I could sort of go around like a viewport. That's how I would like to do winter observing, honestly.
I feel like there's some ice fishing equipment that might serve that purpose.
Oh, that's a good idea, actually. That's a good idea. All right. Well, if any of you out there have an ice fishing hut that you would like to modify into an observatory, let me know. That'd be kind of cool.
One of the things that I posted in the comments was a link to our star maps. And as people start to do observations throughout these upcoming months, I know sometimes the star maps can be a little confusing to use. Can you provide us with just a quick little update on what's the best and easiest way to use star maps?
Yeah, in fact, I can do it very quickly here using Stellarium, if I get my thing right. Here we go. So one thing about Stellarium is you can change our view. And when you look at a star map, you're looking at a basically what we call a fisheye view. Everything's round. And this is not sort of normally the way we think about looking at the sky, but it is the way the sky is. It's round. It's all around us. And it comes to a point overhead we call the zenith. So when you're looking at a star map, like our star maps that we have, you're going to hold it up basically right in front of you. I've actually got a star map here. I've got our latest one, early edition here. So you just hold the star map up right in front of you. I guess Zoom isn't going to help me with this. Hold it up right in front of you. And again, I recommend starting out south. I forgot how to mention to find north very quickly. Our Big Dipper's here, but this time of year, going to jump backwards in time. This time of year, if you really want to find north, I actually recommend looking for a bright W. The constellation of Cassiopeia up there. And from Cassiopeia, let's move around a little bit here. From Cassiopeia, you can trace out a line downwards and then a right angle overwards, and that will point you right to Polaris. So Cassiopeia here, and we'll direct you to Polaris, which will help you find north. All right, sorry, getting off track, I realize. Looking at our star maps. So we've got a star map here. It's a round view of the sky. And what you want to do is you want to hold it up in front of you in the direction you're facing. So let's say that we found north. Great. I'm going to take my star map. I'm going to turn it upside down. North is, you can't see it. It's on the bottom. So north is here. I'm holding it up in front of me. And then what I see near the bottom of the star map, which is this big circle, just like we see here on the screen, everything on the bottom of the star map, that's going to be closer to the horizon. So if you can see down here, we have the Big Dipper, which is going to be very close to the horizon, making it a little bit harder to see. As you come up in the circle of the star map, everything will be higher and higher until you come to the very center. The very center of the star map, the very point in the sky directly above you, that's the zenith. So that's as high up as you can go. And that'll be at the very center of the circle on the piece of paper you're holding. Now, looking at the map, things might seem a little reversed. East is over here on your right, west is over here on your left as we're looking north. You might expect it to be the other way around when you're looking at the star map itself. But if you go outside, it'll make sense. Suddenly, as you look out there, you're facing north, and east is on your right, and west, I hope it's on your left. That's sort of the way it is. It's not totally intuitive until you really go out and do it. But using that basic way, find your direction, hold the star map up, face with the direction that you're looking. So for example, again, facing north, I'm looking at north here on my map. You can find pretty much anything in the sky. And like we did at the beginning with some of that star hopping from the Summer Triangle over to Pegasus, down to Fomalhaut, over to Mars, you can use the constellations on the map to star hop around. So if you're looking for a constellation you aren't familiar with, for example, here, we've got a constellation called Camelopardalis, difficult name. Camelopardalis on my map here, I apologize, I don't have a picture for it. It's a little to the east of Polaris. So if I found Polaris, I'd find Polaris using maybe Cassiopeia here and coming down. And then it looks like it's actually in between Cassiopeia and Polaris. So Polaris is here and Cassiopeia is here. It's in between these two, and then it's just sort of downwards at an angle. If I imagine a straight line, there's kind of an angle pointing downwards, and it's somewhere here. Some of these stars should be Camelopardalis. And it looks like I'm right. Excellent. Wasn't totally sure that was going to work. You never know. Camelopardalis is a very faint constellation. Doesn't have very bright stars. It's also very, it's a giraffe. There's a lot of history with the name and how it got that name. I'm not 100% sure about it, so I encourage you to look it up on your own. I think, Amber, again, long explanation there. Did that help answer how to use a star map?
Absolutely. Thank you. Thank you for sharing those reminders. I think I'm excited to get people out and watching the stars, and in particular getting them excited about some of the cool stuff that we have coming up in November. If you haven't heard, the Bell Museum is going to be hosting a statewide virtual star party all throughout, well, in one long week in November. So November 9th through the 14th. And I'll be posting a link to information about that in the comments. There are a ton of speakers, presentations, and virtual observing events throughout that week that you can register for and participate in. And so we're very much looking forward to all those great opportunities. I want to thank everyone for joining us once again this afternoon. Thank you, Thaddeus, for leading us on our monthly observations into the night skies. I hope that everyone has a wonderful afternoon.
All right, stay warm and stay safe, everyone.